So starting with questions, I think 1 through 18 was what I asked for the homeworks.
Wait, so 1 through 4.
So like, I think at the end of the last lesson, it was 1 through 18 due on 2-4.
It said 1 through 4 on the that's why.
Okay, well, I apologize for not getting that also updated. Okay. Do we have questions on anything up to this point? So homeworks, general questions, life questions. Yes, Ava. The chapter, the section A1?
Yeah.
How about with this Sunday's problem set? Sound good? We'll do the 3 variable stuff today, and then you should be able to finish the last couple of, I don't know, there's like 4 problems or something that we hadn't been able to get to on the Delta Math, or 2 types or something, I think. Anyways, other than that, everybody's okay? This stuff has felt pretty familiar so far? All right. Fair enough. Today, then, we're going to talk about 3 variable systems. So, with 2 variables, with x and y, each of those equations represents a line, right? Everybody's okay? What does an equation with 3 variables represent? Not a parabola. So you have 0 dimension is what type of geometric figure? Yeah, something has 0 dimension. How about a point? Okay. Like there's no left or right or up or down for a point, it is.
It doesn't go anywhere.
Yeah. How about a one-dimensional object from geometry? A line. You can go left or right, but that's it. That's okay. And what's a 2-dimensional object from geometry? That's an element. Or actually, that's a chemical compound. Silicon is the element. Silicone is...
What's it called? What do they call a sphere?
Okay, that's 3-dimensional, though. Cube is 3-dimensional. 2-dimensional.
Oh, it's a regular square.
So, what's a square that goes on in both directions forever?
A very big square.
Not a rectangle. Starts with a P. It's a square that goes in all directions forever.
Everything. Square.
Starts with a P. It's a geometry word.
What?
L.
Plane.
Plane is correct. A plane is like a square that goes in all directions forever, right?
Yeah.
So if you have an equation in 1 variable, that's like a point. It's like a 0-dimensional object. An equation in 2 variables, that's like a line, 1-dimensional object. Equation in 3 variables, that's like a plane, a 2-dimensional object. So if we have a system of 3 equations, that's going to be 3 planes, right? It's going to be a little bit tricky to visualize here. So if we're talking about exactly 1 solution, we're going to have something like that. Notice those three planes, I have a red, blue, and green, are intersecting just at one specific point. That can still happen. But since we're describing this point in 3 dimensions, how many components does our point have to have? It has to have 3 components, right? It has to have x, y, and a z. Can we get infinitely many points or infinitely many solutions? Yes, what does that look like?
Would it have to go through all 3 planes?
It's going to be a line where the 3 planes intersect and make a line instead of a point. You guys see that? And then the third is no solution. What is that going to look like? Okay, so what, like, use your hand. Show me, what do you mean by not intersecting at all? Okay, because there's 3 ways this could happen. One is you have like the 3 planes that are just parallel, right? What else could happen? What if you have 2 parallel and then 1 like perpendicular to them, right? Still no place all 3 of them are going to intersect. And then there's one other situation. What if they make like a triangle, right? Like these 2 planes intersect, these 2 planes could intersect, these 2 planes could intersect, but none of them but no place do all 3 of them intersect, right? You guys kind of see that visually in your head. The pictures help a little bit.
So not all 3 will intersect.
Correct. So again, if two of the three planes intersect, that doesn't mean that there's going to be a solution, because if the third one never intersects at the same place, then you can't have a solution, right? Like anything here would be true for planes, for the red plane and the green plane, but wouldn't satisfy the blue plane, right? Same thing here. Like anything on this line would satisfy the red plane and the green plane, but not the blue plane. And then like on this one, anything that satisfies the red plane doesn't satisfy any of them, the other ones, right? And vice versa. So again, same 2 methods for 3 variable systems that we've used for 2 variable systems. Substitution and elimination. For obvious reasons, we're not going to discuss a graphical method for a 3 variable system because, quite frankly, graphing a 3-dimensional object, like a 3-dimensional object, and placing that in a 2-dimensional space like your sheet of paper is rather difficult and like tough to really like get any kind of perspective about like where the intersection actually is. So we're still going to use the same 2 algebraic methods, substitution and elimination. Now there's some small modifications that need to happen because we have an additional variable and an additional equation.
Didn't we do this on the math?
I did have 3 variable problems in the delta math. I told you that for the delta math you could stop when you got to them because we hadn't done it yet in class. But you might have gone ahead and did it anyways because you probably did it last year and you might have remembered. So not a big deal if you've already done that. So again, substitution starts the same way. You want to isolate a single variable from one of your equations. You're going to then plug that back into the other 2 equations. And then take one of those 2 and solve it equal to a single variable. And plug that one into the remaining equation. And then you'll have one equation with one variable that you can then solve Algebra 1 style and then substitute back. Elimination, kind of the same idea. We're going to start by choosing a variable to eliminate. So you'll add two equations together in such a way to eliminate that variable. And then you'll add two different equations together in a different way, possibly, to eliminate the same variable. The two resulting equations are a two-variable system, and you solve that the same way you would a two-variable system. Let's do some examples. Yeah? Because again, the process here isn't difficult, but it's usually lengthy, and as a result provides lots of opportunities to make mistakes. So we must be careful. All right. Let's do this problem first by substitution, then we'll do it after by elimination. Deal? Okay. If I look at these three equations, which variable and with which equation would be the one I'd want to isolate? Again, trying to make life as simple as possible. In general, it doesn't matter. But like, come on, Mr. Kulik, it matters to me. I don't want to make this harder than it needs to be. Which variable and which equation? I think there is one best answer here.
Solve for y.
Y from equation 3. That's what I would do also. Why did we choose to do that? Because you don't have to divide to do it, right? If I don't have to divide, what can't I create? Fractions. What are my enemy in this problem? Fractions. If I don't have to have them, I do not want to have to deal with them. Everybody agreed? Okay. So I'm going to take equation 3, and I'm going to get the y by itself. So I'll add the y to the one side and add the 1 back to the other, right? Everybody cool? I'm going to take that y then and substitute it back into equations 1 and into equation 2. Does everybody feel okay with what I just did? Okay, so when I distribute that 2 through, I get that. And when I combine like terms, 4x and 12x is 16x. 8z and 3z is 11z. And I'll subtract that 2 over to the other side to get that. I'll distribute the negative 3 through. And when I combine like terms, 2x and negative 18x is negative 16x. Negative 12z and 5z is negative 7z. And then I'll add that 3 over to the other side. There. So I now have a resulting two-variable system. Everybody feel okay here? Now, non-math related point that I need to make, where I see a lot of errors get made, penmanship is some of our enemies. Z's and 2's look an awful lot alike. If you are someone that is going to have trouble differentiating a Z from a 2, I strongly encourage you to cook up a scheme to make it clear to yourself what's a Z and what's a 2. Mr. Kulik puts bars through all of his Z's because if you ask me to draw a Z and you ask me to draw a 2, I can't tell the difference between them anymore. Can you? I know myself and I know what my penmanship looks like. I know that's an issue for me. Okay? I would strongly encourage you that if you are not already drawing your Z's with bars in them, to begin doing so, because at least in math class, you're going to see some Z's and 2's together, and boy, that can be a problem, right? Everybody's okay? All right, let's look at our remaining two-variable system. Now, you could use substitution to solve this, but please don't. Look at what you have. Yeah, let's just do elimination, right? What variable are we going to eliminate? X. How are we going to do it? Just add them together, right? And if we divide both sides by 4, there we go. How do we find our next answer? We go and we plug that back into any two-variable equation. So maybe I'll plug it back into that one. (11 times -3 is -33, right? I add that to both sides. Then you divide by 2. Everybody's okay there? What do I do to find my last part of my answer? I take both of those and plug it into someplace, one of the three variable ones. The one I would choose is that one where the y is already by itself. I don't remember. 1. So the way I'd write my answer is that. Does everybody feel okay? Remember doing this last year? Usually we do, this tends to be in the beginning part of the year where everybody's really trying hard and tends to stick pretty good. All right. What if we tried to do this now doing elimination? So again, my goal is to do this the easiest way possible, right? So I want to start by choosing the variable I'd like to eliminate first. what I would say when I do that is I look for the variable who has a coefficient of 1 or -1. That is the best case scenario for me. Which variable are we going to use or eliminate first? I would do y's, right? Now, x would not be a bad one either, because if I look at the x coefficients, 2 is a multiple of 4, or 4 is a multiple of 2, and 6 is a multiple of 2. So that would be a good one to do. But in general, I'm just looking for a coefficient of 1 or -1. If I have that, that's the variable I'm going to eliminate. If I have multiple variables with that, it doesn't really matter. Just pick whichever one looks easier. Sit. Certainly. All right. So we're eliminating y's. So let's say I eliminate first equation, the y's with equation 1 and equation 2, or equation 1 and equation 3. So to get equation 1 and equation 3 for their y's to cancel out, I need to change the coefficient for the y in equation 3 to be -2. Everybody agree with that? To do that, I'm going to multiply equation 3 by 2. So I'm going to do equation 1 plus 2 times equation 3. Everybody okay there? Next, I'm going to use equation 3 to eliminate the y's from equation 2. What do I need the coefficient for the y in equation 3 to be to eliminate the y's from equation 2? It needs to be +3, correct? So what do I need to multiply equation 3 by to change its coefficient from -1 to +3? -3, right? These two equations now become a new two-variable system. And I noticed right away that this is all set up, tailor-made to eliminate. In fact, it's the exact same elimination problem that we had before, that we can just add the two together. Everybody's okay? Once I have that one answer, I can just plug it back into any two-variable equation. Let's say this one. And once I have two solutions, I can plug those two back into any three-variable equation. Let's just say for the sake of argument I use that one. Again, X, Y, Z. Final answer. All right. So to check your answer, you can plug this back in and make sure it satisfies all three equations, right? Okay. You could also ask your calculator to just do the whole problem for you. You guys seen how to do this before? Okay, well, if you have your calculator with you, I invite you to take it out and follow along. If you have an ACT in your near future, this is a nice thing to know how to do on your calculator. I'm just saying, some of us are juniors in the room. Not all of us are seniors. You're like, I'm already accepted. I don't care about ACTs anymore. Or maybe I'm still suffering PTSD from it. All right. Shh. So, first thing I want to do, if this is going into my calculator, I want to make sure that my system lines up vertically. All the x's line up, all the y's line up, all the z's line up, the equals signs line up, and the solutions all line up vertically. If that's not the case, I'm going to have to do some rearranging to make sure everything lines up. Most often than not, it'll be lined up for you, right? What happens if you are missing like an X or something? Like imagine that this one just looks like that. I just think of 0x there, right? Yep. Good. All right. So to do this in my calculator, the easiest way to do this is to use a matrix. I'm not going to go into like what a matrix is and all the theory behind this and why it works. I'm just going to show you how to do it. Is okay? To access the matrix menu, you're going to press second and then the matrix button, which is just right down there. Your matrices are labeled with capital letters in brackets, so matrix A, B, C, D, E, F, G, etc. What we're going to go to is the Edit tab, and we're going to select matrix A. So this 1x1 here is describing the dimension of our matrix. Right now it's a 1 row and 1 column matrix. The matrix I need needs to have 1 row for each equation, so it needs to have 3 rows, and needs to have 1 column for each entry. So 1 column for x's, 1 for y's, 1 for z's, and then 1 for the solutions. So this needs to be a 3x4 matrix. So rows first, column second. The good news is your calculator is going to make it look exactly like whatever you put in. If you're like, oh, that's not the right shape, you can always just like doodle the dimensions so that it fits. Everybody's okay? Now what I'm going to do is I'm just going to type in the numbers in my equation without respect to the variable. So I'm going to have 4, and then press enter. 2, and then press enter. 3, press enter. 1, press enter. That's my first row. Then I'll do 2, enter. -3, got to make sure I'm taking those minus signs with me. Enter. 5, enter. -14, enter. And then 6, enter. -1, enter. Remember, there's a 1 in front of that y that's not there, but we know we don't write it, but we know it's there. 4, and then -1. Everybody's cool as to how to get that into your calculator. Very simple, right? Basically write it down just like it looks without the variables. You can do this. I have faith. At this point, I'm done in the matrix or entering stuff into my matrix. So I'm going to press second and then the mode button right next to exit back to the main screen of my calculator. And now what I'm going to do is going to retrieve the command RREF. That stands for row reduced echelon form. That's an operation that you can do to a matrix. It does not matter what that actually means. You don't have to know those words. I'm just going to say it. So if somebody says it to you at some point, you're like, oh yeah, that's that RREF thing from my calculator. So to find that command, we're going to press second and the matrix button. This time we're going to go to the math tab in the matrix menu. So I'm just going to arrow over. And I'm going to just scroll down till I find the RREF command. Be very careful because there's also an REF command. You don't want that one. You want the stutter, the RREF. Everybody's okay? I select that, paste it to the home screen. Now I need to tell the calculator, what am I doing RREF on? Our matrix A. So I'm going to go back second and the matrix button. From the names tab, I'm going to pick matrix A, paste it right there, close my parenthesis, press enter. And the last column here is giving you your solution. X, Y, Z. Ooh! That's a time saver on an ACT or whatever if you have to solve a system. Does it work for 2 variable? Absolutely. Or would it work for 4 variables? Yeah. If I'm solving a system on an ACT, would I ever do it by hand? No. I'd let my calculator do it every single time because it's going to be, I have more faith in me typing it incorrectly and not making a mistake than to like grind through a bunch of algebra and not make a mistake. Everybody feel okay? Now, if I look, let's look at what this is actually saying now. Remember how when we entered this system into our calculator, we turned it into a matrix? I can take my matrix and turn this back into a system. So this first row of my matrix means 1x plus 0y plus 0z equals 2. Or really just x equals 2, right? The next row says 0x plus 1y plus 0z is equal to 1, or just that y is equal to 1. The third row means 0z, or 0x plus 0y plus 1z equals negative 3, or just z equals negative 3. Everybody's okay with how I'm reading that? So the question becomes then, Mr. Kulik, what is this going to look like if it's like a no solution or infinitely many solution? If I do this on my calculator, what's that going to look like, right? What do you guys think? Should we try one of those? Well, what might this look like if I had a no solution or infinitely many solutions problem on my calculator? All right. Okay, so let's do this example. Everybody's okay? We're going to do it by hand first. See what we get, and then we'll use the calculator and see what it looks like there. Deal? First question, if you had a choice between substitution or elimination, which one would you prefer? Ooh. I mean, I'm an elimination guy. I think that's almost always the easier route, but you know why I like that one better? Because I can guarantee that I don't have to deal with fractions until the plug-in step. right? If you do substitution, sometimes you just have to deal with fractions. And I don't like having to deal with the fraction if I don't have to. You know what I'm saying? So I'm an elimination guy. But if you'd want to see me do substitution, we can do substitution. Do you guys get what I'm saying, though? Like if there's a coefficient on everything, then there's like you're going to get fractions guaranteed by doing substitution, right? Don't have to do that if we're doing elimination. That's why I like it better. Let's just do elimination. Unless you're like, I'm totally clueless on this. All right. So for doing elimination, which variable would we choose to eliminate? I like z's too. You know why? I don't have to do a multiple of any equation, right? So to eliminate z's, I can use equations 1 and 2, right? And I can just add them together the way they are. Everybody agree? So it gives me 2x plus 2y equals 8. And then I could also add equations 2 and 3. I don't have to do nothing to those either. I can just add them together the way they are. Boy, I love this problem so far, right? 4x plus 4y equals 16. Everybody feel good? I'll make that my new system. This is equation 4, and this is equation 5. To eliminate, well, which one do you want to eliminate, x or y? Doesn't really matter, right? Let's do x's. What do we have to do to eliminate the x's? You mean negative 2. Yeah, negative 2 times equation 4 plus equation 5. So that's going to be negative 4x minus 4y equals negative 16. And then 4x plus 4y equals 16. That gives me the 0 equals 0, right? That's our indicator that we have infinitely many solutions. Now, in a 2 variable system, we just stopped here, right? Because any point on either the 2 lines was a solution, right? So there was like, all I needed was one of the equations for a line. I already had the equation for a line is sitting right there. So here, though, we can do a little bit better. I would like the form of those infinitely many solutions. So let me show you how to get that. So what you're going to do is you'll take either of your 2 variable equations. Doesn't matter which one. So let's just say we take 2x plus 2y is equal to 8. And I'm going to solve that, or I'm sorry, I'm going to get one of the 2 variables by itself, like I'm going to do a substitution. Everybody's okay with that? Doesn't matter which one. Let's, for the sake of argument, get the x by itself. So I'll subtract 2y over, and then divide by 2. Everybody's okay with that? So what I have right now is part of my solution. My x I'm going to write as negative y plus 4. Because I've written my x in terms of y, my y is just going to be itself, y. It's like the independent variable in a function. To get my z, I'm going to take this and plug it into one of the 3 variable equations at the beginning. It doesn't matter which one. For the sake of argument, I'm going to use the first one. and then get the z by itself. Everybody's okay here? So if I combine my like terms, I get negative y and positive y. Those add to give me 0, right? That's unusual. I subtract 4 from both sides, and I'm left with just z equals 0. Oftentimes, z would be an expression of y. Occasionally, it'll be a constant, like we had here. That can happen. So this is one way I could write those infinitely many solutions. So what this is saying is, if you pick a y, somebody give me a number for y. 10. If y is 10, the x-coordinate should be negative 10 plus 6, or plus 4. That's negative 6. The y-coordinate should be 10, and the z should be 0. That's a solution. If you pick a different y, what's another y? 6. If I pick y to be 6, I'd have, for my x, I'd have negative 6 plus 4, negative 2. Y, 6. Z, still 0. That's another solution. And you can see this is a way to generate infinitely many solutions, right? That are guaranteed to satisfy all 3 equations. So when I ask for like the general form of your infinite solution, I'm looking for something like this. And there's going to be usually 3 ways to write it. There's only 2 ways here because z is always 0. But that's the idea. Is everybody okay there? Let's go back and do this on the calculator and see what this would have looked like there. Yeah? Do you remember how to get it in? Matrix, edit, great. I'm just going to type over the stuff I had there because the dimension will be the same. Okay. What looks different about this output from my calculator than the previous one? This is the previous output, right? Notice how I have like this square part on the left has like that diagonal going down there of just ones and then zeros everywhere else. That's what we're looking for if there's a single solution. Do we have that here? What do you notice is weird about one of the rows? Yeah, if I look at the rows of this output, it's all zeros. That row is equivalent to 0 equals 0. That's our infinitely many solutions queue if you get a row of zeros. Everybody's good? Now, Mr. Kulik, can I get that general solution like you just had out of this thing? Well, sure. Do that so we can see the thing. So if I look at the first row, what is that first row saying? It says x plus y plus 0z is equal to 4. Or just x plus y is equal to 4. Right? If I look at the second row, that's like 0x plus 0y plus z is equal to 0, or just z is equal to 0, right? Everybody's okay? If I take that first equation and I just subtract y from both sides, and I put it together the exact same way I did before, look, it's the exact same general solution I'm able to come up with. Is that, you guys see that? Yeah or no? You think so? Yeah. What would it look like? Well, let's try another one, right? Here, you guys get your stuffs ready. Let me put up another one. This, we got lots of time here. Shoot. There it is. This has infinitely many solutions. Come up with the general solution. I'll give you a few minutes to work. We'll go through it afterwards. Try it on your own. Use some pencil lead or stylus or calculator batteries or something. Try it on your own. Oh, shoot. This isn't the one I wanted you guys to do. I know, calm down. I made a mistake. Yes. Look, I wish I would have caught it sooner too. This is the one I wanted. My apologies. Uh-oh.
Well, here, this is what I plugged in the calculator to see. That's what I got.
Stop asking me that. I don't know.
Okay. So if you look at this line, that's saying like 1b minus 1/3 c is equal to 5/3.
Oh, so I do.
Or if you multiplied through by 3, you'd have 3b minus c equals 5, which is the same thing we have here.
Yeah.
So this is right.
Okay. So how would I? So I would write this like.
You can use fractions,
Okay.
but I would just say like 1b minus 1/3 c equals 5/3.
That's one of my answers.
That's a system,
Yeah.
right? Or one equation, and I can solve it for b. Like I can say,
Yeah.
so b equals
Equals
1/3 c
plus 5/3.
plus 5/3. So in the middle column, I'd write 1/3 c plus 5/3, and then c is c,
Yeah.
and then I can take this equation,
So this would be this is
A
like A plus
minus
minus
1/3 c
1/3 C.
equals negative 28
So
thirds,
you just add 1/3 C to A.
and then I just put the and I add the 1/3 over.
Yeah, that's 11.
So I have A equals negative 28 over 3 plus 1/3 c,
Yeah.
and then
All right.
I'm good, right? As long as they're the same variable. That's an equivalent answer.
Yeah, mine looks like that too. Take for the sake, take yoga,
Do biology. Do biology. Such a good class.
No, she wants to do this. Take yoga though, I'm telling you.
Take yoga, it's so nice.
I've taken it 3 semesters.
I wish I took yoga. I'm just so mad at it next year.
I don't know.
I should put that
I did some of
Yeah, that's on my desk.
Don't do AP stats. I'm going to be
Don't do anything.
There's like, I don't know what other options you have though. Besides like this. You still have the IB.
So if you're a current junior, next year you could take your courses options are what you have the IB Math SL, which is not of the options. Okay, so there's that. There's AP Stat. There's the personal finance and math apps. And if you performed exceptionally well in this course, maybe AP Calc. But that's often a stretch. So if we rank them from easiest to hardest, right? The easiest is the math apps, personal finance option. Then probably the IBSL course. And then the AP Stat, and then the AP Calc is probably the order of difficulties. Ava. Easiest personal finance, math apps, then IBSL, AP Stat, AP Calc. I would, so it's hard to say. It's certainly A's are better both semesters. It's probably 95s are better. But those are your four options if you're a rising senior. In general, all of them are harder than this class, aside from the personal finance math apps option. If you're looking for a comparison, which I think is what you want, right? Like you want to balance your schedule. You want to make sure you have something that's manageable. Some people take too many hard classes. Some people take too many easy. Some people want to make sure the hardest class isn't the class that is the one they like the least. Like I'd rather have a hard class on something I enjoy doing because it's not a chore for me to do it than a hard class on something I detest where it's like a chore for me to do it. But that's just me. Some people are wired differently. Do you guys have other questions about that kind of stuff, Ava?
What was that over?
What? Okay, is this an individual question about something you're missing?
Yes.
Okay, we'll deal with that in a second, okay? No problem. Okay. Did you guys get this to work out? I put in the works. I showed you what the RREF looks like from your calculator. Is this okay? All right.
You guys just know.
Yeah, I did the frac command to get it as fractions. There were my decimals.
Yeah, frac.
Right? All right. Clear your desks.
Oh, snap. Oh.
What?
No. Please don't do this to me on Monday.
Wait, hold on. I was like, I didn't learn everything yet. Wait, I got elimination.
That is crazy.
You don't have to do any substitution or elimination.
Oh wait, so I don't need a
Wait,
calculator?
is it just like with the photo map? Not the photo map.
That's a heck of a slap.
Oh, okay, I understood that. You're so jealous.
I'm not gonna do it.
It's crazy. That was so cool. I start crying.
Easy, dude.
You're gonna be were here for the time we learned this.
Yeah.
Your team. No. No.
Guys, I don't. I like
Frick, bro.
Oh my god.
Why did you even
Evil.
He was gonna give us.
So
You should have said you didn't know you were doing.
look at the directions for 1 or 2, 1 and 2. Use your calculator to solve each linear system by graphing. Make sure to list the equations you entered in your calculator and the sketch of the graph from your calculator and the solution. There's not a unique solution, right? No solution or infinitely many solutions when applicable.
Let's go. Do this.
Number 3, solve the system of inequalities. Make sure your inequality is in slope-intercept form. Graph each inequality and clearly identify the overlap of the shaded regions. Okay?
Okay, you do my whole.
Graph.
Oh,
Graph.
no, Eva.
Okay, yeah.
That's not what we're doing.
No, you don't need to do that.
Were you not just listening to what he was saying?
No, I was.
You have
I
to
have
You have to get it
ADHD.
slope-intercept form.
Stop
And then it's your calculator.
Just
Yup.
bring it over, right? Correct?
Yeah, get the y by itself. That's all we're talking
Oh, wait,
about.
you have to get the Y by itself. Oh my god.
That's what slope-intercept form is. Yes.
Okay, but
Y
then
by
you
itself.
put it into calculator.
Then it goes in the calculator.
Okay.
Yeah.
What makes the guy so much? Hey, I got it.
No, just get the y by itself. And then put it in your calculator and find the intersection.
Oh, whoa. Don't use that
Wait,
link.
can I have a question? Yeah, but you put Y.
Slope-intercept form is the y by itself, right? I mean, you have to use algebra to rearrange it. You can't just like move the things around when you feel like it.